comes out of 8.2 derivatives of exponential functions. So now that we know what the derivative of e to the x is, we can use that fact to take derivatives of things like this: y equals x cubed times e to the x. So hopefully this brings out to you as a product or a question. I say the first function times the derivative of the second plus the second function times the derivative of the first. If I factor that a little bit, I can take out clearly an e to the x. I can also take out an x squared, and what I'll have left over here is x plus 3. Most commonly, actually, what you write here is x squared e to the x, times x plus 3. From there, you could do anything in terms of finding critical numbers, increasing, decreasing, etc., and we'll do some examples of that later on. So let's try differentiating this one. Y equals e to the cosine x. So we're still in the situation where we have the variable up in the exponent, so we still think of it hopefully the same way, where the first part of this derivative is just e to the cosine x, but then I have to say times the derivative of cosine x, which is negative sine x. And so basically what we have here is a chain rule. If I had y equals e to the x to the 7, the derivative is going to be e to the x to the 7 times 7x to the 6. So in general, your chain rule basically says if you've got y equals e to the some function of x, the derivative is going to be that times the derivative of that function of x that was in the exponent. So we can carry on and do some more, I guess, more complicated derivatives. Let's say we have, I'll call it example B, I suppose, for this one. Y equals e to the negative 5x times sine of 3x. Well, this should jump out at you as both a product rule and a chain rule. And say the first function times the derivative of the second, so that's cos 3x times 3, and then plus the second function, sine 3x, times the derivative of the first, which is e to the negative 5x, times the derivative of negative 5x, which is negative 5. So you do have to keep things straight, just as you did in the last chapter when you're doing chain rule. There definitely is a common factor here, which is e to the negative 5x. And what do I have left over? I have 3 cos of 3x minus 5 sine of 3x. Sine of 3x.